Okay, great. So I'm happy today to walk you through our research project about automating GDPR compliance checking. It is a research project in collaboration with researchers from HEC Paris and Oranova. So our work comes from the context of complying with the data protection laws. So complying with the GDPR is challenging. And one of the reasons is that personal data flows in complex data supply chains. And although companies are using technology to deal with this complexity, there isn't a comprehensive framework defining end-to-end compliance. So the objective of our research is to fill this gap by first building a conceptual framework for GDPR compliance, and second, to test this framework by automating the compliance checking of privacy policies against the GDPR. The framework that we developed is document-centric because the GDPR entrusts documents with different functions. For example, controllers and processors must maintain a record of processing activities according to Article 30. So the starting point of our framework are compliance documents that we define as documents that establish the conditions and processing activities that data controllers and processors are intended to and should carry out. Such documents are privacy policies and data protection addendums. It could be also contracts containing clauses about data protection or internal company documents. And so these documents, we suggest that they should be automatically analyzed first to ensure their compliance with regulation, both on a functional level and substantial level. Then the documents should be compliant in the data supply chain, which means that we verify the documents in the light of contractual standards or another document with a higher hierarchy in the supply chain. And last, we assess the adequacy between operations, documents, and regulations, so that we also ensure that operations of processing personal data are compliant with the regulations. To test our framework, we first apply it to analyze privacy policies compliance in the data supply chain. And we start with privacy policies because they are the compliance documents that appear at the top of the data supply chain, since they communicate information to data subjects. And we define the tasks to check for formal compliance, which is the first level of the compliance framework we suggest. And the tasks that we end up with are the checking of the presence of mandatory information according to Articles 13 and 14, and also the readability and clarity of the language, which is defined in Article 12 of the GDPR. And in this research project, we focus on the first task, which is the detection of mandatory information. So our system is composed from two modules. The first one segments privacy policies into paragraphs, and then we predict data practices from each paragraph. The data practices are then used as input to the second model of the system, which is a rule-based model, in order to detect the mandatory information that are mentioned in the privacy policy. And first, I will walk you through the algorithms we built for the extraction of data practices. So we use machine learning and as a training data set, we used the OPP 115 corpus, which contains 115 privacy policies annotated and publicly released by researchers of the Usable Privacy Project. And as you can see, the taxonomy is hierarchical and it is composed of 10 categories of data practices. And here we show only the categories that we used for the compliance checking. And each category has a set of attributes, and each attribute has a set of predefined values. So here we have an example of an annotated segment from IMDb privacy policy. And the annotator first selected the first party collection use category. And this category has different attributes, such as personal information type. And the annotator selects the values of these attributes by reading this segment. And the annotator also highlights the text in the segment that corresponds to the value. So for example, for the value computer information, the annotator highlighted login password. And so since the taxonomy is hierarchical, first level, we have the categories, and each category has children attributes. And for each attribute, we need to predict the values. We treat this problem as hierarchical multi-label text classification task. And we experiment with two approaches. We first try the local classifiers approach, and then a second approach, which is based on a text-to-text framework. The training dataset is composed of 115 privacy policies, which is small in comparison to the label's size. So in order to obtain good performance, one common ingredient for both local classifiers and text-to-text approach is to use transfer learning, where first a language model is pre-trained on a large data set of online text, and then the learned knowledge is transferred to train data practice predictor on the dataset of annotated privacy policies. So for the local classifiers approach, at the training time, we need to train one local multi-label classifier to predict the higher level categories, and then one local multi-label classifier for each attribute to predict the values for that attribute. And as you can see here, the training for this set of local classifier is done independently from each other. And at inference time, the predictions are made in a top-down order, where first categories are predicted by the higher level local classifier. And then for each attribute associated with the predicted categories, so for example, if we only predicted this category, we would only use the local classifiers associated with these attributes in order to predict their values. And for the local classifiers, we choose to use the same local classifier for all the levels and the nodes. And we first reproduce prior work by the authors of policies and use a convolutional neural network as the base classifier. Segments are first embedded with word embeddings that were trained on more than 130,000 privacy policies. And this allows us to have a good baseline to compare with the other approaches. And since the state of the art these recent years is transformers for NLP tasks, so we conduct a second experiment by using a transformer model, and precisely the ExcelNet model, which we first used the pre-trained one, which is publicly available, and then we fine-tune it first for the prediction of the categories, and then to predict the attributes values, which means that we fine-tune it 21 times for the 21 tasks. And here are the results for both tasks and for this approach of local classifiers, and by both the convolution neural networks model and the ExcelNet model. And as you can see here for the first task, ExcelNet has superior performance comparing to CNN for the task of categories prediction. However, it has a significantly lower performance than CNN for the second task. And we think that it is the case because there are enough examples to fine-tune ExcelNet for the first task, but not enough for values prediction, given that ExcelNet is much larger than CNN. And so the results are of the classifiers are good for certain tasks and categories, but the local classifiers approach has two main drawbacks. The first one is that it trains the set of local classifiers independently, so the classes hierarchy isn't captured, and the classes hierarchy is important if we want to improve the predictions of the values. And the second drawback is that the number of classifiers grows linearly with the size of the label hierarchy, which means we need more compute power and time, both for the training time and inference time. To deal with these limitations, we suggest to use a text-to-text approach. Why? Because text-to-text frameworks cast every NLP task into a text-to-text problems, such that both the input and output are text. And the main advantage of this is that we can use the same model for all the NLP tasks. So for example, even this task of computing the semantic similarity between sentence 1 and sentence 2, which is a regression task since the output is a number, could be converted to a text-to-text task, and it could be solved using the same model that was used for translation or for summarization. And we use T5, which is a pre-trained language model based on the transformer architecture to implement the text-to-text approach for our task of data practices prediction. We first need to convert the task of extracting data practices into text-to-text. We do this by first splitting this task into two tasks. The first one is to predict the categories for the segment, and the second one is to predict then the values and also the span of text corresponding to the values. And we prepare the first task of categories prediction by prepending the categories prediction prefix to the text of segments. And for the target, we convert it by generating a sequence of the categories and separating them by a semicolon. And for the second task, which is the prediction of the values, we convert it to similarly to read and comprehension task, where we use the prefix values prediction and context to indicate to the model what is the segment from which we want to predict the values and also extract the text. And we give it also the category in order to keep the hierarchy in the model, and also the attribute for which we want to know the value. And the target is transformed by first by starting with the span of text we want to extract, and by putting between brackets the value of the attribute. Once we pre-process the data and we convert it into a text-to-text format, we fine-tune the G5 by fine-tuning the largest available model, which has 11 billion parameters on these tasks. And we try two fine-tuning methods. So G5 could either be fine-tuned in an independent way, such that we first fine-tune it on the task of categories prediction, and then on the task of values prediction. And in this way, we have two models. And the second way to do it is to fine-tune it in a multi-task setting on a mixture of both tasks to capture the global labels hierarchy. And when we look at the results, we see that the both ways of fine-tuning have close recall and for both tasks, but the precision is significantly higher when we fine-tune on each task separately, which is what the authors of G5 recommended. And the performance for span extraction is good for a baseline, but we think that it is low in comparison with the performance of the same model T5 on similar tasks such as reading comprehension or named entity recognition. So we need to work more on this task. And as a global comparison between the two approaches of local classifiers and text-to-text, both XNet and T5 performs significantly higher than CNN for the first task, but the performance is at best similar to CNN for the second task. And for later experiments, we select to work with the T5 because of both the performance and is also capable of doing span extraction with which the local classifiers cannot do. And once we finish extracting the data practices, then we feed them to the second model of our system in order to detect the mandatory informations. Here we list the mandatory informations that our legal experts were able to encode using the OPP taxonomy. So this taxonomy was created before GDPR, so we weren't able to encode all the mandatory informations because it doesn't contain all the concepts needed for the GDPR. And we choose JSON logic to serialize obtained rules because it comes with a parser that we use to build a first order logic inference engine with Python. And here is an example of encoding a rule that states the obligation of mentioning the purpose of the processing of personal data. And for evaluation of this part of mandatory information, we created two data sets annotated with the mandatory information, 15 pre-GDPR privacy policies and 15 post-GDPR privacy policies. And we noticed that most of the errors on the OPP privacy policies are caused by the difficulty of aligning OPP concepts with GDPR. So, for example, to encode data retention period, we use the retention period attribute. However, it doesn't correspond to what is required by the GDPR. And in the other hand, the majority of errors on the post-GDPR policies are when the algorithm does not detect the right to data portability. And this is expected because data portability has not been widely adopted before the GDPR. And so the training data set didn't contain that concept, and therefore the algorithm and inference time wasn't able to capture it very well. And the bonus with the G5 is that it is capable of predicting new categories of data practices due to its language understanding capabilities that enable few and zero-shot inference. So when we gave segments from post-GDPR privacy policies, it was able to predict new categories that weren't in the training data set, but that they correspond to concepts from GDPR articles such as legitimate interest or data minimization. And this could be helpful if we want, for example, to create a GDPR taxonomy from compliance documents. And to conclude our work, I like to say that this work consisted in the creation of a framework to implement automated GDPR compliance in the data supply chain. And we proposed an automatic way based on machine learning and a rule-based model to implement the detection of mandatory information from privacy policies. And we also dealt with the limitations of local classifiers by suggesting a text-to-text framework. And you could test with our approach since we released the models and data sets that you could find on GitHub. And for future work, we would like to apply the compliance framework to other documents such as the DPIAs and define what would be the compliance tasks to verify the compliance of these documents, implemented in a way that takes into account that companies and work with multi-documents. So we need to check in a multi-document setting. And of course, create data sets that are annotated with GDPR taxonomy, especially if we want to work with other compliance documents. So thank you all for your attention, and I would be happy to answer any questions.
Thank you very much, Mrs. Hamdani, and also Mr. David Restrepo here with us in the Zoom room for your brilliant presentation, your brilliant paper. We have collected a few questions from the audience, and I would like to pose the first question from Mr. André Eller from University of São Paulo, Brazil. So Mr. André Eller says, in which level of applying NLP do extracting information from legal documents could, in fact, shape the law? Isn't there a risk of such rules to be tautological?
I think David could answer this question much better than me. We had several discussions about it. Let him answer.
Thank you, Andrea, for the question. Let's make sure I'm understanding the question right. So I guess what we are, what we are trying to do in this paper is to identify the provisions in privacy policies that contain some legal obligations in relation to protection of data, and to verify their compliance to GDPR. So the risks or the way this can shape the law, if we think about the pipeline that Rajaa described at the beginning of the paper, which is checking compliance in the supply chain, this meaning in the different contracts between processors and sub-processors or subcontractors. The risk is that the extraction of information through NLP from the documents becomes the main focus of compliance checking. By becoming the main focus of compliance checking, ultimately becomes in practice, what actors are interested to comply with. So in other words, that we comply with what can be verified or can be extracted with NLP from legal documents. At least this is what the audit, if this can be implemented, could mean. So we have been working in this project with industrial partners who have this compliance chain, and potentially the fact that we extract some information from these privacy policies or privacy documents could mean the focus of compliance, and then legal obligations will be there. And if there is a risk that such rules become tautological, I'm not really sure exactly what it means. Maybe that we are always extracting, because of the way the tool is designed, the same type of rules from the text. Andrew, correct me if that's...
Yes, it is.
Yeah, so indeed, I mean, I guess what is interesting from the paper we just showed, so I agree as a base with what you're with that. What we can take from this paper in addition to that is that there is the possibility of predicting categories that were not originally in the data set. And I think this is an interesting progress that we made in this paper, showing that there is a way of going beyond the training data set. But of course, there is some limitations to that. So there is indeed a risk. And I guess without giving much more detail, that's why we need some decision-making process that has humans in the loop to be brief in the answer. Thanks for the questions. I think the second one, it's more for Rajaa, but I'm happy Rajaa to take a little bit on it as well.
Yes.
Mhm.
I would like just to read so the public can have it as well. We have here in our private chats the second question, but also from Mr. André Ele from University of São Paulo. So Mr. André says, would it help if laws were written in UML models so there is no margin for different interpretations about it, at least in the field like compliance to data protection?
Yeah, I think this would definitely help. I'm not sure to what extent is possible, and I let David like extends on this. But for me, as a like data scientist, this is something that would help me greatly, if, especially for example, creating the training data set and the taxonomy that goes with it. So I would like not only maybe to that laws are written in a machine readable format, but why not, if we're going to use machine learning to automate, why not give also examples of training data that could automate some parts of these laws.
Maybe the only thing I can add to that is I would think that a slightly different but similar approach would be to do what the GLML consortium is doing. I don't know if you're familiar with it. It's called General Purpose Legal Markup Language. And this is used mostly for trading bonds in markets. And the idea of this GLML is it's a general purpose language markup, as I mentioned before. And the idea is that it's both machine readable, so it's a markup language, and human readable. So basically allowing some automation in the execution of transactions, bonds and others, but at the same time allowing review by lawyers of the documents. So I think this is an interesting way forward that we could use also for data protection.
And I would like to add that so for the compliance checking, the there is an intermediate step actually of building then what is the checklist that we want to check, and this is like which we convert into learning tasks. So so even I think if we have the laws written in UML models, we still need to build this checklist for the compliance checking.
Thank you very much, Mrs. Hamdani, Mr. Restrepo, for your brilliant work. Now you have one last minute for final words, and then we follow with our next paper.
Yeah, so for final word, I would like to thank all the team that worked on this paper. It was a great collaboration both between two institutions and also to kind of profile data scientists and legal experts, and also would like to address to the community the need that we need to create data sets such as this, but that are adapted to GDPR.
Thank you very much for your presentation, Ms. Rajaa. It was very interesting. Now I will ask you a question from the audience. Our first question is it possible to formalize in logical terms open textual rules, such as the lawful base, legitimate interest? What are the main challenges to implement this task?
Thank you, Leonardo, for communicating this question. So it's a good question, especially the example of legitimate interest. We tried to encode legitimate interest with the OPP taxonomy, but we couldn't because we didn't find the right concepts to encode it. And we also tried to define with legal experts what are all the possible ways of mentioning legitimate interest, or what are the rules. And that also was difficult because it's very, very large. But a data-driven approach is promising because one of the concepts and categories that was predicted by T5 in the zero-shot setting is legitimate interest. So if we annotate the expressions of legitimate interest on privacy policies or any other documents, I think a natural language processing approach would be able to extract the legitimate interest or other open textured concepts from the text given its context.
Okay, thank you. And we have a second question that is, your experiment is focused on privacy policies. As you mentioned, the intention to adapt the framework to other documents such as the BIAs. What are the main challenges for this adaptation? And if I could complement this question, I would kind of ask you to comment the possibilities of using in this framework existing privacy ontologies like Pronto that are compliant with some GDPR policies.
But, so our framework is could be adapted to other documents because the levels of compliance that we defined are defined in a way, an abstract way, in order to take into account all the compliance documents of GDPR. So the first step would be to look into those levels and then define, apply them to the DPIAs in order to define what would be the compliance tasks for the DPIA. And then for in terms of extracting automatically the information, compliance information from the DPIA, that's when we would need to create a training data set, since the data set that we have is doesn't contain all the GDPR concepts that we need. And that's where ontologies of GDPR like Pronto would be helpful to annotate the documents. And there is also one that was created specifically for the DPIA. It's called DPMF, and it contains the concepts needed for the DPIA. So I think the main challenge for this framework to work, especially the automatic information extraction, is to annotate enough documents with the GDPR concepts that are important for compliance checking.
Okay, great. Thank you very much. And
you.
you have 1 minute left. Would you like to make any final considerations?
I just would like to thank you all, thank the organizations for this great work and organizing such a conference that holds across time zones, especially.
Yeah, it's a challenge.
Thank you. Yes.
Thank you. So congratulations for your interesting presentation.